All right, let's dive right into this explainer and kick off our investigation into a really fascinating astronomical mystery, one that's sitting about 1,860 light years away from Earth. We're going to explore how looking at distant starlight is literally forcing scientists to completely rethink the roles that electricity and magnetism play in shaping our universe. Because, this isn't just about what we can see through a lens, it's about the invisible architecture of space itself. Think about Caldwell's 75, which you might also know as NGC 6124. It's this absolutely breathtaking open cluster of about 125 member stars hanging out in the Scorpius constellation. It was actually first discovered way back in 1751 by Abbé Nicolas Louis de Lacaille. And on the surface, yeah, it's just a stunning collection of stars. But the gorgeous starlight reaching us from this cluster is actually carrying a hidden, encrypted message about the cosmic forces at play out there in the interstellar medium. So when astronomers look really closely at the light traveling from Caldwell 75, they notice something weird. It's strangely polarized. Normally, starlight just scatters everywhere, in all directions. But by the time the light from this specific cluster actually hits our telescopes, the light waves have been organized and restricted to very specific orientations, which of course forces us to ask the obvious question. What invisible force is out there altering the starlight before it even reaches us? Well, the answer actually lies in a microscopic process happening in the vast, seemingly empty spaces between the stars. Interstellar dust grains are constantly rotating, and as they spin, they pick up this tiny magnetic moment. This makes them wobble, or precess, along magnetic field lines in space until they perfectly align themselves with those cosmic magnetic fields. Once they're aligned, they act exactly like a massive cosmic polarizing filter for the starlight passing through them. So the dust is literally mapping invisible magnetic fields onto the light we see. It's pretty amazing. Now here is where things get really weird. When researchers analyzed 46 stars in the Caldwell 75 region, they found that the mean polarization angle is roughly 8.1 degrees, and that is a massive anomaly. Here's why. The expected projection of our Milky Way's galactic plane in this exact region is about 44 degrees. Over time, dust particles should just relax and align with that main galactic field. But an 8.1 degree angle? That completely misaligns with what we'd expect to see. That unexpected angle is a huge clue. It tells us that the starlight isn't just passing through some uniform, standard galactic field. Instead, there's a local magnetic field associated with a nearby dark filament called the Lupus cloud, which is sitting right between us and Caldwell 75. It's actively disrupting the broader galactic field. The dust in the Lupus cloud basically hasn't had time to relax into the main galactic orientation, so we are witnessing a distinct, localized magnetic perturbation in real time. This optical polarization is such a clever tool because it allows us to essentially see these totally invisible magnetic fields in the Scorpius region. By observing how the starlight is filtered, we map those fields out. But right here is where we hit a highly debated pivot point in astrophysics. Where exactly do these massive magnetic fields come from in the first place? I mean, how are they generated and sustained across literally light years of space? Mainstream astrophysics will often claim that the turbulent mixing of conducting fluids, like gases in a star or plasma in a galaxy, is what generates these fields. But electrical engineers, like Donald E. Scott, fiercely criticize this theory. In fact, in his analysis of magnetic phenomena, Scott goes as far as calling this fluid mixing theory an appalling lack of knowledge about how magnetic fields actually originate. He points out, quite rightly, that you can mix, boil, or centrifuge conductive fluids all day long, and no magnetic fields are going to magically appear just from the mixing alone. To find the real culprit, we absolutely have to look at Maxwell's equations. And these aren't just, theoretical guesses. They're based on rigorous experimental measurements by pioneers like Gauss and Faraday. These equations prove an undeniable causal law of physics. You simply cannot have a magnetic field in space without an electric current to generate it. Magnetic fields don't just exist out there on their own. They are the direct, immediate result of electric charge in motion. The interaction of these forces works a bit like this. A primary electric current creates a magnetic flux. If that primary current is constant, the resulting magnetic field stays constant. But if that primary current fluctuates, getting stronger or weaker without even changing direction, that changing magnetic flux induces a completely new secondary current in any nearby conductive material. It's a process called transformer action. And the crazy thing is, it is the exact same principle we use in the electric power industry right here on Earth every single day. Now, applying this principle to an actual star, like our sun, reveals something super fascinating. If a primary cosmic electric current flows into the sun, and that current fluctuates over time, transformer action takes over. That changing primary magnetic field induces secondary electric currents on or just beneath the sun's surface, and those create their own looping magnetic fields. If the primary current simply strengthens and then weakens, the secondary surface current will actually reverse its direction, which, brilliantly, cleanly explains the enigmatic 11-year reversal of the sun's magnetic poles, without the main cosmic current ever needing to change direction. So here is the crucial takeaway. Looking at magnetic fields only leaves astronomers really struggling to explain what actually drives the cosmos. It completely fails to explain the formation of double layers, or why magnetic fields suddenly move and cause explosive events like solar flares. Because, let's be real, magnetic fields don't have some self-initiated volition to just snap together. But acknowledging magnetic fields plus electric currents provides the actual causal mechanism for these explosive events. These currents are the unseen engines powering regions all across the universe, just like what we're observing in Caldwell 75. Now, as researcher Michael Clarage notes, there is a catch here. Cosmic electric currents are incredibly difficult to observe directly from a distance. A massive current can flow through a cosmic plasma and give off very little direct signal to our telescopes. But this is exactly why the polarized dust in open clusters like Caldwell 75 is so incredibly important to us. The polarization gives us the vital data we need. We might not be able to physically see the cosmic electrical wires, but by observing how the magnetic fields align the dust and polarize the light, we can absolutely infer the presence of the massive electric currents driving them. As we wrap up this explainer, we're basically left staring at a vast, invisible electrical web. The anomaly in the light from Caldwell 75 isn't just some random quirk of astronomy. It's a signature of electromagnetism at work on a galactic scale. And honestly, it forces us to wonder, if the space around a distant star cluster in Scorpius, 1,860 light-years away, is actively driven and shaped by unseen electric currents, what other massive cosmic mysteries are out there, just waiting for an electrical explanation?